All right, so we have been learning about how to find the area of polygons, and we're going to use that knowledge that we have acquired, and we are going to take a look at some not so regular polygons. We're going to call those irregular figures, and we are going to find the areas of those figures. We can also do things where you find the perimeter as well, so we'll look at that a little bit as well. To make sure that we understand how to do that. And we're going to start with the area here first. So what we're going to do is we're going to take those and we're going to break the shape up into figures that we know. So if I look at this one, you're like, well, I can look at it as a square and a rectangle. I could see that here. I could also think of it as a smaller rectangle up here and a bigger rectangle down here. For me, I'm looking at, I feel like this square is already labeled and this piece is already labeled, and so those are just ready to go. If I cut it into the smaller one, I would have to think of that as 22 and then think 23 minus 20, so that little side is 3. So there might be some extra steps that I would need to do there to find the measurements that I would need. So my first step, I'm going to do rectangle 1 here. So in rectangle 1, to find the area, I'm going to do length times width, and 23 times 22, and that gives me an area for just that first rectangle of 506, and its area, so that would be centimeters squared. Now I have a second part to my figure here, and it is a square there. So in my square, see if we can darken those a little bit. In my square, I am going to have side squared. So my side length is 20, and 20 squared is 400 centimeters squared. So that means I have 506 plus 400, and I'm going to get 906 centimeters squared for the area of my irregular figure there. My next figure, I can once again, there's no curved parts to these, and I don't see any triangles that would be helpful, so I see rectangles there again. And you might see two different ways of thinking of it again. You might think of it as a rectangle up here and a rectangle down here, and you might notice that there are two of those, so you could find one and multiply it times 2. And then a rectangle here. I could have also cut it this way and had one long rectangle and then two little squares here. So there's multiple ways that you can usually cut these up. And in this first one right here, this rectangle right here, and I'm going to call this 1A, and I can think of this as 1B because they are the same. They are the same size rectangle. I've got a 3 for my width and I've got a 6 for my length. So my first step is I'm going to find the area of the two congruent rectangles. And then I'm going to find I need to find this length right here. I'm going to find the third rectangle's dimensions and then use that to find the area of the third rectangle. So the area of those congruent ones, I have, once again, the area is going to be the width times the length, which gives me 18. Now we said we have two of those that are identical, so that was 36 centimeters squared, and that is for both of them. Each one of those rectangles is the 18 centimeters squared. So there's part 1. Part 2, I'm going to find these dimensions. Well, if this is 3 and this top part is 6, that means this part right here is also 3. So I just found the width of that rectangle. If this whole piece here is 11 as it's labeled, and this part is 3 and this part is 3, so I'm taking this 3 away and this 3 away, that leaves me with this middle part as 5 centimeters. Can't see that. Let's try again. 5 centimeters. So for my second part here, my area of my rectangle is going to be 3 times 5, which is 15 centimeters squared. And I only have one of those, so now I'm to the point where for step 3, I'm going to add the area of the rectangles. So I have 36 plus 15, and I get 51 centimeters squared for my total area of that irregular figure. My third example here, you'll notice a triangle. And I'm not going to try to do anything fancy to that. I'm just going to go, this is my triangle right here. So for my steps, I'm going to do the triangle. I'm going to do the square. I noticed it was a 16 by 16, so I knew right away that it was a square. And then I'm going to combine them. I'm going to add them up. So to find the area of my triangle here, I know I need the height. And that's labeled on the outside. In this case, my height is 24. So the area is 1/2 times the base times the height. And like I just said, I know that this is 24. Well, my base, it says that this is 7.5, and it says that this is 7.5, and then this is 16 up here. So I'm going to need to do 7.5 plus 7.5 plus 16. I get 14 there and 30, so 31. When I do that multiplication, put in 0.5 for my half times 31 times 24, and I get 372. And that is inches squared this time, and that is just my triangle. My square here, I'm going to do my sides squared, so I get 16 squared, which I believe is 256 rather. And then I'm going to combine these. So I'm going to do the 372 plus the 256. So 628 inches squared there. Sorry, I didn't realize I was slid the paper. So I did the triangle again, I did the square, found the area of each, and then I combined those two areas to find my total area of my shape. My last one here is a little interesting. It looks a little off center, but as long as I can see that I have a triangle up here and I can go ahead and close that off, I can see that the height of my triangle, which is labeled on the outside at this time, but the height of my triangle is 21 meters. And from here I know that the base of my triangle is 32 meters. And then I just have a triangle and a rectangle. So I'm going to take care of my triangle first. Then I'm going to get my rectangle. And then I'm going to add the two to get the total. So for my triangle, make sure I don't lose you here this time. For my triangle, I find that my area, once again, is 1/2 times base times height. And my base is 32, and my height is 21. So 0.5 times 32 times 21. And I get 336 meters squared. And then for my rectangle down there, that is just that length times width again. So that is just 32 times 11. I That gives me 352. And then once again, I need to combine these. So I'm going to add them up, and I get 688 meters squared. So that is how we find the area of irregular figures.